Hi, welcome back. Today we're going to learn a little bit more about solving quadratic equations by factoring. Don't forget a few reminders. Email me if you ever have any questions or need any extra help. It's definitely not too late to turn in late work. Email me if you have questions about that. Make sure that you have out your pencil and paper and be ready to take notes. Make sure you're using your school address. The homework will not allow you to submit until you are logged into your school email address. I noticed that some of you are entering made-up answers or IDK on the IP. These do not earn credit. You get 0 points. On the last IP, there was a question like x squared plus 3x minus 2 is equal to 0. Is that in standard form? One answer was 34, and one answer was IDK. We could do better than that. That's a yes or no question. If you don't know, you should go back to your notes, or you should email me and get extra help on that. Struggles or celebrations. If you've been paying attention at all, you know that I don't often cook. My husband does most of the cooking and I clean up the dishes. But this week I found that we had canned pumpkin, a pie crust, and whipped cream in the freezer, so I decided to make a pumpkin pie. It was like Thanksgiving in April here. What are you snacking on this week while you're in quarantine? Right now, I want you to pause the video and complete the bell work below. Remember, it's really important to keep practicing these problems so that you don't forget everything while we're gone. You're also going to need to be able to factor today, so make sure that you know how to do these before we move on. Welcome back. You should have noticed that A was 1 and C was 4, so you should have started with A times C, which is 4. You're looking for two numbers that multiply to be 4, but you also want them to add to be B, which is also 4. Your magic numbers there are 2 and 2. We can then write this out, x squared plus 2x plus 2x plus 4, and factor by grouping. Factor out the x, that leaves us with x plus 2. Factor out the 2, that leaves us with x plus 2. So we're left with x plus 2 times x plus 2. The shortcut that we learned last time, which only works if a is 1, was that you could have skipped this step and gone straight to here. If a is 1, then you can just write your binomials, put the correct signs, and then put your two magic numbers. Remember, that only works if a is 1. For this one, you should have noticed that there was a GCF of 2. So we take the 2 out, so that leaves us with 3x squared minus 8x plus 4. A is not 1, so we can't use the shortcut on this one. Our new A is 3, our new B is negative 8, our new C is 4. I'm looking for two numbers that multiply to be 12 and add to be negative 8. You should have gotten negative 2 and negative 6 for those magic numbers. This becomes 3x squared minus 6x minus 2x. It doesn't matter whether you put the negative 6 or the negative 2 first, you get the same answer. And remember, it's not plus 8, it's plus 4 here. I'm going to change that to plus a negative, group those two together, group those two together. The GCF here is 3x, so that's x minus 2. I'm going to take out a negative 2 to make the signs match, so that's x minus 2. We have 3x minus 2 times x minus 2, and don't forget the original GCF was 2. Good job! Our lesson for today is called More on Solving Quadratic Equations by Factoring. The focus today is to get more practice with solving quadratic equations by factoring. However, if you did not do the previous lesson to this from last Wednesday and Thursday, I want you to go ahead and stop here and go back and do that lesson. It's always a good idea to do your e-learning in order and not jump in into the middle. So some quick review. What are the 3 steps to solving a quadratic equation by factoring? Well, you want to write your quadratic equation in standard form. Remember we learned last time that standard form is ax squared plus bx plus c, which you're used to, but now we want it to be equal to 0. Then we're going to factor, which all of us should be able to do by now, and if you can't, then you need to be in an office hour. And then we use the multiplicative property of 0. Find the zeros. And that just says that if we have two things multiplied together, if a times b equals 0, then either a could be 0 or b could be 0 to make that work. A common mistake on the IP. Some of us are confused on how to write an equation in standard form. The problem below is from the IP from last class. It asks, is x squared plus 2x equal to negative 3 in standard form? And here were your answer choices. Well, remember, the whole point of standard form is to get the thing equal to 0, and this is not. So if we write it out here, if I want to make it equal to 0, then what I need to do is add 3 to each side. in order to make 0, negative 3 plus 3 is 0. None of these are like terms, so that's x squared plus 2x plus 3 is now equal to 0, which means you should have said that your answer choice is C there. If you have questions about how to do that, make sure you log into an office hour and we can work on that together. All right, let's do some review. Would you please right now try to write these in standard form? Pause the video and try these on your own. Welcome back. You should have started by adding 18 to both sides here to make 0 on the right-hand side. So we have x squared plus 9x plus 18 is now equal to 0. For this one, you should have subtracted 5 from each side. That'll get 0 on the right-hand side. Then it's 3x squared plus 11x minus 5 is equal to 0. All right, the zero product property to find the zeros of the quadratic equation. So go ahead and pause this now and try these on your own. Welcome back. You should have separated these. We have two things multiplied to be 0. Remember that was the example I gave a while ago. A times B equals 0. Either A could be 0 or B could be 0. It works the same here. We have to split this up into two problems. 4x minus 1 equals 0 and x plus 2 equals 0. And then just solve like you would a normal 1 or 2 step equation. So x could either be 1/4 or x could be negative 2. Either thing would make this whole thing equal to 0. For this one, you should have split it up into 2. W plus 1 equals 0. W minus 9 equals 0. So W could either be negative 1 because I need to subtract 1 from each side, or W could be 9. Either negative 1 or 9 are your answers there. All right, in order to factor, we have to start with trinomials so that we can identify our A, B, and C terms. I want you to write the following binomials as a trinomial. Don't forget that these should be in standard form. Ax squared plus bx plus c equals 0. So let's look at example 1. Let's see if we can figure out what we're missing because it's already equal to 0, so this piece is good. It's got an x squared, so this piece is good. It's got a constant, so this piece is good. What it doesn't have is the bx. Well, the number that we use when there's nothing there is 0, so I can just add that into the middle. Now I have an a, a b, and a c. Exact same idea here. We've got 2w squares. We don't have any w terms, so we add that into the middle and write plus 8 equals 0. Pause the video and try example 3 on your own now. You should have noticed that you're missing an r term, so that's r squared plus 0r minus 121 equals 0. Good job. Let's start with a quick application of solving quadratic equations. A relief package is released from a helicopter at 1,600 feet. The height of the package can be modeled by the equation h equals negative 16t squared plus 1,600, where h is the height of the package in feet and t is the time in seconds. The pilot wants to know how long it will take for the package to hit the ground. Well, let's start by putting this in standard form. Negative 16t squared. Notice there's a missing t term, plus 1,600. And then in order for the package to hit the ground, how far off the ground is it? What's our height? Well, the height is 0, so we can just replace h with 0. Now we're going to factor. We're going to take a 16 out. So that leaves me with negative 1t squared plus 0t plus 100 equals 0. Now we are going to multiply a times c, so that gives me negative 100. I'm looking for two numbers that multiply to be negative 100, but add to be 0, and those numbers are negative 10 and 10. This becomes negative 1t squared minus 10t plus 10t plus 100 equals 0. I'm going to put the first two together, the second two together. I'm going to factor out a negative 1t. That leaves me with t plus 10. These have a 10 in common. Both can be divided by 10. That leaves me with t plus 10. Now I'm left with negative 1t plus 10 on the outside of the parentheses and t plus 10 on the inside of the parentheses. So now it says to use the zero product property to find out how long it will take for the package to hit the ground. So we have negative 1t plus 10 is equal to 0, and t plus 10 is equal to 0. minus 10 from each side. I get negative 1t equals negative 10. Divide both sides by negative 1. So t equals positive 10. For this one, that's minus 10 from each side. So that's negative 10. Well, let's think about what it is that we're trying to find. This means 10 seconds ago. That's how long ago that the relief package was on the ground. We want to know how long it's going to take for it to hit the ground again. So we're going to use the positive 10 seconds. Good job. All right, so let's do some examples of solving quadratic equations by factoring. Well, don't forget, we have to have a trinomial. So I'm going to replace that missing term with a 0. I noticed that a is 1, so I'm going to show you how to use the shortcut on this one, and then you can try it on your own here in just a second. We're going to do a times c, so that gives me negative 9. I'm looking for two numbers that multiply to be a times c, but add to be 0. Those numbers are negative 3 and 3. In order to use the shortcut, we write our two binomials. It's always going to be n in the first one. Remember, this only works if a is 1, not n squared. Those are just n's. And then our two magic numbers are the second pieces of those factors. That's equal to 0. So we rewrite this as n minus 3 equals 0, n plus 3 equals 0. Add 3 to each side, so n equals 3. Subtract 3 from each side, so n equals negative 3. Pause the video, you try this one on your own. Welcome back. You should have replaced b with 0k. You should have multiplied a times c. That gives me negative 4. And I want these to add to be 0, so that has to be negative 2 and 2. To use the shortcut, I set up my two binomials. I use a negative 2 and a positive 2. Now I can use the multiplicative property of 0 to set both of these equal to 0. So k equals 2 and k equals negative 2 on this one. Good job. All right, let's look at example 3 here. Well, before I replace b with 0, I noticed that there's a GCF, so I'm going to take that 2 out. That leaves me with x squared minus 16 is equal to 0. Now I can rewrite this as 2 times x squared plus 0x minus 16 equals 0. I'm now looking for two numbers that multiply to be negative 16 and add to be 0. Those numbers are negative 4 and 4. I took the 2 out, so it is a part of our factors. But if I use the shortcut, I can set those up with the two binomials. The x's first, and then minus 4 and plus 4 is equal to 0. I can't make 2 equal to 0, so we just throw that one out. I could make x minus 4 equal to 0 by adding 4 to each side, so I know x is 4. And then x plus 4 equals 0, so x equals negative 4. So my two answers there are 4 and negative 4. Pause the video and try example 4 on your own now. You should have factored out a GCF of 3 first, which leaves you with x squared minus 25. You should have then recognized that you needed to add in a 0x for the b. Then we notice that we can use the shortcut on this one because a is 1, so we're going to find two numbers that multiply to be negative 25 but add to be 0. Those numbers are negative 5 and 5. The shortcut means that I can set up my two binomials and put the two magic numbers inside the parentheses. 3 cannot be made equal to 0, so we throw it out. It's impossible. But x minus 5 could be 0 by making x equal to 5. Or x plus 5 could be 0 by making x equal to negative 5. Good job. Great job today. I want you to go to the Haiku page, find the link for more on solving quadratic equations by factoring IP. Then you're going to use the video, your notes, and office hours to complete the IP. Email me if you have any questions or concerns. I'm here to help. Thanks, guys.